So in this video, I'm going to assemble the hardware, and I've made a PCB. I've got videos on my channel which show you how to etch PCB and how to design one using some software called KiCad. And I print out the silk screen layer to help me have a guide as to how to assemble. The first thing I'm going to do is I'm going to put in place the dual inline socket for the microcontroller, because that holds the silk screen sort of in place onto the PCB. And I'll solder that in place. When I solder dual inline sockets, what I usually do is I solder two pins at opposite corners first. And I just pick up the PCB, just hold my finger on the actual socket itself, and just push it whilst I resolder those joints. And that just makes sure it's close to the board and it's not hanging off the board at all. So I'll finish soldering those pins. Generally, it's a good idea to do the lower profile components first. So I'm going to put in the 82 ohm resistors. I'm not going to spend too much time getting it neat. I should really pull these through. So I'll now solder those into place. Cut the legs down. Next I'll do the 120 ohm resistors in the same way. I'll solder these into place as well. Now I'll cut the legs on these. So now I'll do the resistor and the transistor for the sound. So I put the 4 switches in next. These can be a bit tricky. So I'll solder the switches in. Next I'll put the LEDs in. It doesn't really matter what order they go in, but I've written on the silk screen the colours. It's important to get the positive towards the left edge, so the smaller of the inside pins towards the left, towards the edge of the board, because that's the positive track that goes along there. Now I'll solder the LEDs in. It's a bit tricky doing this whilst filming, so some of the joints are really poor, but I'll probably reflow those. Yeah, that's the top of the board done. I've actually got a couple of components to put on the bottom of the board. Now the board is actually designed to be double-sided, but I can only make single-sided board at home. So I'm going to have to fiddle this a bit, or just hack it a bit to put it together. The positive goes towards the inside of the board for the speaker. Push it in a bit like that, and I'll solder it as best I can at a bit of a height. I'll probably melt the case a bit of this, but it's just for until I get some double-sided boards made. Put a decent amount of solder on, because what I'm going to do is I'm going to melt the solder and push the component down to make it closer to the board. So I have to do the same kind of thing with the battery clip. I do it slightly differently because it's harder to get to. So first of all I put some solder on the pads where it's supposed to go. And I also have to tin the connectors a bit on the back of the battery. Just to make sure that it get a connection when I reflow the solder. It's a bit messy. Okay, so the positive is towards the speaker, the negative goes over this side. I try and get the positive one terminal in first. It's a real hack this, but just because of the way I've designed, because I wanted to get the battery and the speaker on the bottom of the board so I could reduce the size of the board. And try and get it in the hole there. And then line up the bottom pin to do the same. I'll probably get it better in the hole off camera, but that's generally how it goes on. I've got a capacitor to put on, which is a bit of a hack because I didn't include that on this design of the board. But what if I put the microcontroller in now? Hopefully it should just work if I put a battery on it. Oh, put that in the wrong way around. Make sure I get the integrated circuit in the right way around. Hopefully that should work if I put a battery in there, because I don't think I've got any shorted circuits. And there it is, it's working. And the beeper's working as well, that's good. So now all I have to do is just put this capacitor on in a place where I've decided to put it, which is just there. So it goes between a positive and negative line down there. And that will be this board assembled. So here's a completed board, and I've put the capacitor on, which is the next design of the board. So in the next video, I'll start talking about the software, and I'll break the software down into simple steps, and I'll put each step in a separate video, just to make the videos short, and then you can pick whichever videos you need to watch to learn the bits that are in that video. And then in the very last video, I'll open source the full source code of the project.